Okay, so today we are going to talk about how we find congruence in right triangles. So we got some theorems and postulates that are going to be specific to right triangles. So just quickly a review of right triangles. This is our hypotenuse. It's always opposite the right angle. We know that that's a right angle because of that little square means that it's a right angle. And then the sides that make up the actual right angle are called the legs. All right, so we have the hypotenuse leg theorem. And the hypotenuse leg theorem, or HL, says that if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and leg of another triangle, then the triangles are congruent. So I've got a right triangle. Okay, I know that because of my markings. And I've got DE congruent to AB, and that's a leg. So I have ED congruent to BA, and then I have the hypotenuse. By the markings, they're both 16 inches. DR congruent to TA. Okay, I've got the right triangle, so then my triangles are congruent. So triangle DER is congruent to triangle ABT, okay, by hypotenuse leg. So that's how the hypotenuse leg theorem works. So we have conditions that must be true in order to use our right angle theorems. The first is that you got to have two right angles, which makes sense, or right triangles. The triangles have a congruent hypotenuses for hypotenuse leg and hypotenuse angle. And the triangles have at least one pair of congruent legs for leg, leg, and leg angle. So let's go ahead and do this proof. We're given that ON is congruent to ML, and we're given that LP is congruent to PN, and we know that OPN is a right angle. All right, so we're going to prove that these are congruent. I'm going to start out with the fact that angle OPN is a right angle. And of course, you know me, I like to abbreviate. And that's given. I'm going to split the givens because we're going to use this fact that OPN is a right angle to do a couple different things. We know then that the measure of angle OPN is 90 degrees, and we know that by definition of a right angle. And we know that angle LPM is congruent to angle OPN, okay, because vertical angles are congruent. Okay. So that means their measures are equal. The measure of angle OPN is equal to the measure of LPM by definition of congruence. And then by substitution, we can say that the measure of angle LPM is 90 degrees. We can then say that angle LPM is a right angle. And that would be by definition of a right angle. We can say that our triangles are right. So triangle OPN and triangle MPL are right triangles, and that's by definition. And now we can say that our other givens, ON is congruent to ML and LP is congruent to PN, and that's given. And now we can say that our triangles are congruent by, this is my hypotenuse, this is my leg, so by hypotenuse leg. Okay. So we have these other right angle theorems, the leg, the hypotenuse angle, and the leg angle. And they basically say the same thing that all of them do. If the corresponding legs of one right triangle are congruent to the corresponding legs of another triangle, then the triangles are congruent. But what I want you to notice is that actually leg is the same as side angle side. Okay, I've got a side, an angle, and a side. If I have hypotenuse and an angle, doesn't matter which one I choose, it's angle, angle, side. Okay. Leg angle, so leg and an angle could be angle, side angle, but if it was this angle up here, it would be angle, angle, side. So they're really not new postulates or theorems, but we just, if we have the right triangles, we can use these specific theorems. All right, so today you learned the hypotenuse leg, the leg, the hypotenuse angle, and the leg angle theorems to prove triangles are congruent.